What does it truly mean to be at the absolute top of the software engineering world? When you hear apex engineer, do you picture that legendary 10x coder who just churns out lines of code faster than anyone else, maybe leaving a trail of, exhausted colleagues behind them?
That image, the solitary genius, the lone wolf coder, it's actually pretty outdated now. The whole industry has really shifted its perspective on that.
It certainly has. Today, we're taking a deep dive into a fascinating concept from a blueprint called the apex engineer, a strategic blueprint. And this isn't about being some kind of coding hermit.
No, not at all.
It's about a fundamental paradigm shift. An apex engineer isn't just someone who codes well. They transcend mere coding ability to become what the blueprint calls a force multiplier.
Right, influencing the entire value delivery pipeline.
Exactly. Technology, business strategy, even the human dynamics of teams. It's broad.
It's truly about evolving from being purely a doer of tasks to becoming a genuine enabler for others, creating impact far beyond just their own keyboard.
And our mission for this deep dive is really custom tailored to help you understand that evolution. We're going to break down this path into 5 core pillars, offering like a strategic roadmap for navigating your own journey to the pinnacle of this profession.
And just to be clear, everything we're discussing today comes directly from that comprehensive guide, The Apex Engineer, a strategic blueprint.
Okay, let's unpack this then. We've got to start with the absolute non-negotiables, right? The foundational competencies. These form the bedrock of an elite engineering career. Think of these as your entry ticket.
What's really crucial to grasp here, I think, is that these aren't just separate skills you check off some list. They're interconnected. They form a system.
Ah, okay.
So understanding one area deeply often illuminates and, strengthens your capabilities in others. Like, take mastering your chosen programming language and its underlying paradigms.
Right. The blueprint really emphasizes deep mastery over just broad familiarity. It argues it's actually far more valuable to truly master one versatile high-level language like Python or JavaScript or Java than to have just superficial knowledge of many.
And mastery here means really knowing it, understanding its standard libraries, its idiomatic usage, how it performs under different conditions, its core execution model.
It's like knowing your primary tool inside and out, not just how to swing it.
Precisely. And while that deep language mastery is absolutely key, internalizing concepts from different programming paradigms is also vital. Think object-oriented programming, OOP, and functional programming, FP.
Why both?
Well, it cultivates a far more flexible problem-solving mind. For an apex engineer, it's not about rigidly sticking to one or the other. It's about understanding why things like encapsulation and OOP help prevent unexpected side effects, or how immutability in FP can make concurrent systems less prone to those really subtle bugs. It just gives you a broader toolkit.
Now, here's a topic that gets a lot of attention, maybe for the wrong reasons sometimes. Data structures and algorithms, DSA, often seen as just interview prep, right? But why is DSA consistently identified as the single most important technical skill? What makes it so foundational?
That's a great question because it really is so much more than just a hurdle for interviews. DSA proficiency is, well, it's a direct proxy for your problem-solving ability, your logical thinking, your understanding of computational efficiency. Beyond hiring, it's absolutely foundational for a senior engineer. Think about preventing performance bottlenecks. An apex engineer almost instantly knows whether, say, a hash map or a tree is the right choice for a specific lookup scenario.
Because they understand the trade-offs.
Exactly. They grasp the performance implications, the big O notation, how efficient an algorithm is as the data scales. They're thinking about computational cost before they even write a line of code. This means mastery of arrays, linked lists, stacks, queues, trees, graphs, sorting, search algorithms, the whole 9 yards.
Okay, so beyond the theoretical, there's the modern toolkit. Fluency and productivity with your daily tools are, well, paramount. Take version control.
Oh, absolutely. Proficiency with Git is non-negotiable for any kind of modern collaboration. An apex engineer isn't just doing Git commit and Git push.
No.
They're expertly navigating complex branching strategies, confidently merging and rebasing, untangling really challenging history sometimes. They use Git like a precise surgical tool, not just, a hammer.
And their IDE. Top engineers seem to wield integrated development environments like IntelliJ or VS Code, almost like extensions of their brain. They're powerful command centers.
That's a good way to put it. They're not just typing code. They're leveraging intelligent code completion, static analysis, integrated debuggers, maybe even custom scripts. It's all about maximizing efficiency.
And this extends beyond your local machine, right? The whole life cycle matters.
Definitely. A foundational knowledge of the entire software development lifecycle, the SDLC, and DevOps principles is crucial. This includes understanding continuous integration, continuous deployment, CI/CD pipelines, not just as buzzwords, but how they contribute to rapid, reliable software delivery.
And methodologies like Agile and Scrum.
They internalize those too. This whole holistic view ensures that their code isn't just functional, but it's also easily testable, deployable, and crucially maintainable within a team.
And finally, under this foundational pillar, a true Apex engineer doesn't just write code in a vacuum. They deeply understand the machine and the network their code actually runs on.
Exactly. A solid grasp of operating system fundamentals. It's like having X-ray vision for your code. It helps you troubleshoot those really tricky issues, things related to memory management, process scheduling, multi-threading, the file system.
Things that can seem totally unrelated to your code sometimes.
Right. I once spent days chasing a performance bug, convinced it was my brilliant algorithm, only to discover a simple file system lock was the culprit. It's about being able to truly look under the hood.
Makes sense.
Similarly, proficiency with SQL and database management principles, security, data integrity, backup strategies, that's essential because, let's face it, data is often a company's most valuable asset.
Can't argue with that.
And in our hyper-connected world, understanding core protocols like TCP/IP and HTTP is indispensable. You need it for designing resilient APIs, debugging connectivity issues, and really understanding the performance implications of network latency.
So it all ties together.
That's the powerful insight here. These aren't isolated topics. A deep understanding of hash maps from DSA directly informs how you think about database indexes. OS concepts are essential for writing robust concurrent code. Networking protocols inform every single decision you make about API designs. This holistic systems-level view. That is the true definition of deep technical expertise.
Okay, so once you have that rock-solid foundation, the journey pivots. It shifts from merely writing correct code to designing entire systems. This feels like the big leap, right? From skilled coder to true software architect. This is what gets you into those senior principal roles.
That's it exactly. It's about building software that isn't just functional today, but is also scalable, maintainable, and resilient enough to evolve over years, not just weeks or months.
And that transformation really begins with the art of software design. It's about elevating code quality from just, a craft to a true art form. Writing code that isn't just functional, but is actually a pleasure to read. Code that's genuinely easy for others to modify without accidentally introducing new bugs.
It's almost an act of empathy, isn't it, for your future self and for your teammates?
Like that.
And that empathy leads naturally to internalizing core design principles. These aren't rigid rules, they're powerful heuristics, guides. Think about DRY. Don't repeat yourself. Simple idea, huge impact in reducing duplication. Keep it simple, stupid. Champion simplicity over needless complexity. Keep solutions elegant. And yae jinai, you aren't going to need it. A wise caution against building features for some imagined future need that might never happen. Prevents bloated, over-engineered systems.
Okay, and for object-oriented programming specifically, the blueprint talks a lot about the solid principles. Single responsibility, open-closed, Liskov substitution, interface segregation, dependency inversion. That's a mouthful. For someone listening who isn't maybe deep in OOP theory, what's the essence here? Why does an Apex engineer care so much about solid? What core problem do they solve?
That's a great question because they can sound really academic, but their core purpose is actually quite simple. They're like a developer's guide to writing code that's not just functional right now, but also flexible and easy to maintain over the long haul.
Okay.
For example, the single responsibility principle just means each piece of your code, like a class or a function, should really have one clear job. That makes it much easier to change or fix something without accidentally breaking other unrelated parts of the system.
So modularity.
Exactly. An Apex engineer understands how each of these 5 principles contributes to creating systems that are highly modular, extensible, and maintainable. Systems that can adapt as the business inevitably changes.
And moving beyond individual code snippets, top engineers need to be fluent in the language of software architecture, understanding the crucial trade-offs in different patterns, not just following the latest trend.
That's absolutely right. It means they have a really comprehensive knowledge of major architectural styles. Things like layered or N-tier architectures, event-driven architecture, EDA, and of course, microservices.
Microservices, everyone talks about them.
They do. And an Apex engineer understands the nuanced trade-offs involved. While they're popular for enabling independent team development and, faster deployment velocity,
Which just sounds great.
it does sound great, but they introduce significant complexity because you're dealing with a distributed system. Debugging becomes harder, monitoring is more complex, ensuring data consistency across services is a real challenge. They often require a mature operational capability, maybe even dedicated platform teams.
So choosing microservices isn't just a tech choice.
Not at all. Choosing between a monolith and microservices is fundamentally a strategic business decision with real cost and capability implications.
You mentioned earlier that software architecture isn't just about the diagrams. Could you elaborate on that? What does that mean in practice for an Apex engineer?
Absolutely. Industry thought leader Martin Fowler put it brilliantly. Software architecture isn't just the pretty diagrams you might draw on a whiteboard.
Right.
It's fundamentally about the shared understanding within the development team of how the system is actually structured. An Apex engineer gets that if the team doesn't collectively grasp the architecture, it quickly breaks down in practice, no matter how elegant the diagram looks.
So communication and collaboration are key to architecture too.
Immensely. This is why collaborative practices like pair programming, clear documentation, and just constant communication are so valuable. They build and maintain that shared mental model of the system.
And an Apex engineer is always designing systems for the real world, thinking about scalability, resilience, performance.
Yes, they have to be masters of scalability strategies. Understanding vertical versus horizontal scaling, how load balancing works to distribute traffic, the critical role of caching, and generally how to design distributed systems that can grow massively without needing a complete painful re-architecture down the line.
And designing for failure.
Designing for resilience and fault tolerance? Absolutely. Operating under the assumption that components will eventually fail. It's inevitable.
So you plan for it.
You plan for it. Implementing redundancy, replication, fail-safes, often guided by concepts like the CIP theorem.
Can you quickly unpack CIP for us? Consistency, availability, partition tolerance.
Sure. In a nutshell, the CIP theorem tells us that when you're building distributed systems spread across multiple machines or networks, you face a fundamental trade-off. When the network has problems, partitions, you can generally only guarantee 2 out of these 3 qualities. Consistency, everyone sees the same data at the same time. Availability, the system always responds to requests. And partition tolerance, the system keeps working despite network splits.
So you have to choose.
You often have to choose which 2 are most critical for your specific application when things go wrong. An Apex engineer understands this fundamental trade-off and designs their systems accordingly, making conscious decisions about where to compromise.
And critically is security. It can't be an afterthought.
Definitely not. Integrating security into every single stage of design is non-negotiable for them. This includes things like ensuring encryption for data, both when it's stored at rest and when it's moving in transit. Implementing secure authentication and authorization using standards like OAuth or JWT, and applying defensive coding practices constantly to prevent common vulnerabilities like SQL injection or cross-site scripting, XSS.
They view security as integral, not additive.
Exactly. It's part of the system's core integrity from day one.
Yeah. To manage all this complexity, especially in large systems, top engineers often rely on established patterns and methodologies, right? Like classic design patterns.
That's right. A thorough knowledge of classic patterns, factory, singleton, observer, decorator, and many others provides a shared vocabulary and reusable solutions. It saves countless hours reinventing the wheel.
And what about domain-driven design, DDD?
For complex business domains, DDD offers a really powerful strategic framework. It emphasizes creating a rich, shared model of the business logic that's reflected directly in the code. This ensures deep alignment between the software and the actual business objectives it's meant to serve.
Which brings us back to something you said earlier,
Which was?
that the choice of software architecture is fundamentally a business decision, not just a technical one.
Ah, yes. An Apex engineer is adept at translating technical decisions into tangible business impact. They can explain the trade-offs clearly. For example, explaining how adopting microservices might enable more rapid product iteration, but it also comes with higher operational costs and might necessitate building a dedicated platform team. They need to speak the language of both engineering and the bottom line.
Okay, so we've covered the deep technical foundations and the architectural mastery. While that technical skill is absolutely the price of admission to this level, this next section, this feels like what truly separates the top, say, 1–5% of engineers.
I agree.
These aren't just soft skills. The blueprint frames them as a complex, interconnected system of non-technical superpowers that amplify technical prowess into broad organizational impact. And the ultimate output here, it seems, is trust.
That's perfectly put. And right at the core of these non-technical superpowers is communication. It's not some auxiliary skill for an apex engineer. It's a core competency, almost indistinguishable from their technical ability in terms of importance.
They become the translator. Someone who could take really complex technical ideas and explain them simply, clearly, bridging that gap between the technical folks and the business folks.
Absolutely. Articulating intricate system architecture to fellow engineers 1 minute, and then pivoting to explain the profound business implications to executives the next, all in terms everyone can actually understand.
I've seen this happen. One engineer clearly explaining a system bottleneck to a CEO. It unlocked significant investment because the business impact was suddenly crystal clear.
That's a perfect example. And excellence in written communication is also vital for them. You see it in well-crafted documentation, precise emails, insightful technical articles or RFCs, requests for comments that don't just share knowledge, but actively shape and influence the technical direction of an entire organization.
And they're skilled at leading discussions, not just taking part. They can guide conversations, build consensus even when there are strong, differing viewpoints, and steer groups towards sound technical decisions. How do they do that?
Through their credibility, certainly, but also through active listening and just masterful facilitation skills. They create an environment where good ideas can surface and be debated constructively.
And beyond the code itself, Apex engineers have developed really strong business acumen.
Yes, they possess this deep curiosity to understand the why. Not just what they're building, but the underlying customer problem, the core business objective. This allows them to effectively challenge assumptions and suggest truly impactful solutions, rather than just, blindly executing on requirements passed down.
They also seem to have strong systems thinking, the ability to see the entire puzzle.
Exactly. How their piece of code interacts with other components, how it fits into the broader business ecosystem, and critically, how failures in one part can cascade and affect others. This holistic view is crucial for avoiding those local optimizations that might actually harm the overall system.
And they need pragmatism, a sense of compromise.
Very much so. They understand that perfection is often the enemy of the good enough. They have a keen sense of when a system is ready to deliver value, skillfully balancing time, cost, quality, and features without getting bogged down in endless theoretical debates or gold plating.
Now, leadership in engineering. The blueprint argues it isn't really defined by a title, right? It's more about action and influence.
Absolutely. An Apex engineer demonstrates leadership daily by mentoring junior engineers, providing constructive code review feedback that actually helps people grow, and actively fostering a truly collaborative and supportive team environment.
And crucially, they play a huge role in creating psychological safety within a team.
Instrumental. They help build a blameless culture where mistakes are genuinely seen as learning opportunities, not reasons for punishment. They encourage questions, make team members feel safe to experiment, to fail sometimes, and to learn from it without fear of retribution.
That sounds like the bedrock of a high-performing team.
It truly is. This is how teams really thrive and innovate.
And all this ultimately makes them that force multiplier we talked about earlier, elevating the performance of everyone around them, improving processes, raising the bar for engineering excellence, and scaling their positive influence exponentially across the organization.
And underpinning all of this is what the blueprint calls the apex mindset and the consistent habits that go with it. This includes things like the joy of tinkering.
Just playing with tech.
Yeah, a genuine passion for technology, constantly experimenting with new frameworks, new tools, almost as a form of play, just to keep their skills razor sharp and discover new possibilities.
There's also intellectual honesty and humility.
So important. Being candid about what they don't know, being genuinely open to feedback, and being willing to learn from absolutely anyone, regardless of their title or years of experience.
And the habit of continuous improvement, never settling.
Right. Rejecting the notion of perfect systems, viewing software as an ongoing work in progress, always looking for ways to make things incrementally better, safer, faster, clearer.
And I like this one. Strong opinions, loosely held.
Ah, yes, a classic. It means having well-reasoned opinions based on deep experience and data. But, and this is the crucial part, being genuinely willing to change their minds when presented with compelling new data or superior arguments. It's not about ego or being right. It's about collectively finding the best solution.
Finally, under this non-technical umbrella, sustaining high performance. This isn't a sprint.
Absolutely not. The journey to the apex is a marathon. So actively managing your energy, recognizing the signs of burnout, and taking steps to avoid it is key for longevity.
And recharging beyond the pixels, getting away from the screen.
Essential. Making time for activities completely outside of technology hobbies, physical exercise, family, whatever it is crucial for recharging, gaining fresh perspectives, and maintaining long-term productivity, and frankly, joy in the work. It's too easy to let the screen consume everything.
Okay, part 4. Reaching the apex isn't something that just happens to you. The blueprint stresses that it requires proactive strategic management of your career. It's about intentionally building your reputation, expanding your network, and actively seizing opportunities when they arise.
Exactly. And one of the most potent accelerators for an apex engineer is actively building your brand and reputation, especially through writing.
Writing, like blogging.
Yes. Regularly publishing technical content, blog posts, articles, maybe even white papers, forces you into true mastery of a subject. You can't explain it well if you don't deeply understand it. Plus, it serves as a very public demonstration of your expertise, establishing you as an influential voice in the broader tech community.
And similarly, public speaking seems important too.
It is, progressing from maybe small internal presentations to giving external talks at meetups or conferences. It dramatically hones your communication skills, builds your network within the community, and demonstrates your knowledge to a really wide audience. It often starts small, though, like a simple brown bag lunch presentation to your own team.
And contributing to open source or building side projects.
Also incredibly valuable. Contributing to open source projects gives you invaluable experience working on large, complex code bases, often with diverse groups of people. It hones your collaboration skills. And building impactful side projects creates a tangible portfolio of your abilities that often speaks much louder than just a resume.
Your network is also highlighted as a critical asset.
Definitely. But networking should be approached as a long game. It's about building genuine, long-term relationships based on mutual respect and, ideally, a giving-first mentality, offering help, sharing knowledge, rather than just looking for immediate transactional opportunities.
Finding mentors and peers.
Crucial. Proactively seeking out mentors for guidance is smart, and building a strong network of peers for collaboration, bouncing ideas off, problem-solving, and just mutual support. It's like creating your own personal advisory board.
How do you find these people?
Engaging the broader developer community is key. Through online forums, local meetups, conferences, just getting involved, sharing what you know, and learning from others.
Now let's talk about proactive career management. Being the CEO of your own career, so to speak. The blueprint suggests a really practical habit, keeping a detailed work log.
Yes. This sounds simple, but it's incredibly high impact. Track not just the task you completed, but the quantifiable impact of your work.
Like what?
For instance, instead of just fixed off bug, write refactored authentication service, decreasing average API response time by 150 meters and eliminating a class of security vulnerability. That kind of specific, impact-oriented data is invaluable for performance reviews, promotion cases, and building a compelling resume.
And you absolutely need to step outside your comfort zone regularly.
That's where the growth happens. Actively seeking tasks, projects, or even roles that stretch your abilities. Maybe volunteering for a cross-team project, taking on the on-call rotation if you haven't before, perhaps even changing teams internally. These are key drivers of accelerated learning.
And here's a strategy that feels maybe a bit counterintuitive. Apply for stretch roles, jobs you don't feel 100% qualified for.
It's a powerful one. The interview process itself, even if you don't get the job, is a potent learning experience. It forces you to study new topics you might not otherwise encounter and gives you invaluable insight into what top companies are really looking for at that next level. You always walk away smarter.
Okay, finally in this section, the art of the deal.
Yeah.
Compensation and transitions.
Yes, knowing your worth is critical. Periodically dipping a foot into the hiring market, maybe interviewing casually every year or two, even if you're happy, provides crucial real-time data on your market value, and it keeps your interviewing skills sharp.
What about job changes? How often is too often or not often enough?
It's a balance. Changing jobs every, say, 2 to 3 years is often the fastest way to accelerate salary growth, especially earlier in your career. But staying longer, maybe 3+ years in a role, allows for deeper project ownership and the invaluable experience of seeing the long-term architectural consequences, good and bad, of your decisions.
So there's no single right answer.
Probably not. The optimal strategy often involves a thoughtful mix of both approaches throughout your career, depending on your goals at the time.
And salary negotiation.
Mastering negotiation is genuinely one of the highest leverage skills you can possibly develop. It can result in significant differences in lifetime earnings. This involves doing your homework, diligently researching market rates for your role, experience, and location. Crucially, never naming the first number in an offer discussion if you can avoid it. And meticulously preparing well-reasoned counteroffers based on your value and research. It's a skill well worth investing time in learning.
All right, part 5. As your career progresses, the strategic decisions become, well, fewer, perhaps, but their impact becomes far more significant. These choices, especially, can define the entire arc of your professional life. Things like whether to specialize and whether to pursue technical leadership as an individual contributor in IC or as an engineering manager.
That's right. In a field as vast and constantly evolving as software engineering, developing some form of specialization is often a key strategic move for an apex engineer aiming for maximum impact.
How do you choose a niche?
It should be a deliberate decision, ideally balancing your genuine personal interest with market reality. Researching emerging trends is important, assessing your existing skills honestly, and considering your long-term career goals. Experimenting via side projects is often the absolute best way to test the waters of a potential new niche before committing fully.
The blueprint highlights several high-growth, high-impact fields where apex engineers are really making their mark today. For example, the AML engineer.
Huge field right now. These are the folks building, training, and deploying machine learning models, managing the complex data pipelines that feed them. They need to be fluent in Python, tools like TensorFlow or PyTorch, and increasingly things like large language models and vector databases.
Barely needed.
High demand across tech, obviously, but also finance, healthcare, e-commerce, automotive, almost everywhere.
Or consider DevOps and SRE site reliability engineering.
Right. This isn't just about writing scripts anymore. It's about automating infrastructure, automating deployment through robust CI/CD pipelines, and fundamentally ensuring the reliability, scalability, and performance of mission-critical systems. They're masters of cloud platforms like AWS, GCP, Azure, containerization tools like Docker and Kubernetes, and infrastructure as code tools like Terraform.
What's the core focus for an apex SRE?
It's really about anticipating failure modes and designing systems that not only withstand failures, but can recover gracefully, often automatically. Their work impacts the entire operational efficiency and stability of a company.
Okay, let's talk about the two big paths at the senior levels. Individual contributor, IC versus management. The blueprint makes it really clear these are two distinct parallel paths to leadership and impact. It's not a single ladder where management is the only next step after being a senior engineer.
That's such a critical distinction to understand. The engineering manager, or EM, track. This path scales impact primarily through people.
What does that mean day to day?
Their core responsibilities include hiring great talent, mentoring their team members, guiding career development, ensuring projects get delivered effectively, and crucially, aligning the team's work with broader business goals. Success for an EM is largely measured by the effectiveness, morale, and overall output of their team.
Okay, and the other path, the principal or distinguished engineer, the IC track.
This track scales impact primarily through technology, architecture, and strategy. These individuals are often the organization's foremost technical experts. They're the ones tackling the most complex, ambiguous technical problems, often spanning multiple teams or even the entire company. They set technical direction, drive innovation, and mentor other senior engineers.
And their success is measured differently.
Yes, typically by the broad technical health, scalability, resilience, and innovation of the systems and platforms they influence, the sheer technical leverage they provide.
What's really fascinating, though, is how the blueprint suggests the lines between these roles are blurring somewhat.
They really are. Being a senior IC, like a principal engineer, is by no means a refuge from people problems. To be effective, they must have exceptional communication skills, the ability to influence without direct authority, and strong strategic thinking to guide technical decisions across teams.
And conversely, for managers.
Conversely, a truly effective EM needs deep technical credibility. They need to understand the technical challenges their team faces, participate meaningfully in design discussions, and earn the respect of their engineers. It's not enough just to manage tasks.
So the choice isn't really just about, do I want to code or do I want to talk to people?
Not really, no. It's much more nuanced. It's more about the primary domain of problem solving that genuinely energizes you? Are you most invigorated by tackling deep, complex technical challenges? Or are you more energized by navigating complex organizational dynamics and helping people reach their full potential? Both involve leadership, communication, and strategy.
So if we quickly compare them head-to-head, core focus for IC is scaling impact through technology.
And for the EM, it's scaling impact through people.
Primary responsibilities for IC: complex technical problems, architectural design, innovation.
For EM, hiring, performance management, team building, removing roadblocks.
Success metrics for IC: broad technical impact, system scalability, innovation.
For EM, team effectiveness, project delivery, team morale, retention.
And the career progression maps illustrate these parallel paths clearly. IC goes staff principal, OS distinguished, maybe fellow.
While EM goes EM not senior manager, DSINDO director, DESA VP, potentially CTO. Both are legitimate paths to the highest levels of leadership and impact in engineering.
So, pulling this all together, what does this mean for you, the listener? The journey to becoming an apex engineer is clearly a multifaceted, continuous evolution. It stretches far, far beyond just mastering any single technology. It's really a comprehensive approach to building an impactful career.
If we connect this all back to a core philosophy, I think one really emerges from the blueprint. Technologies themselves are ephemeral. They come and they go. Frameworks change constantly. But the underlying principles of good design, problem solving, collaboration, they endure.
So anchor your career to principles, not tools.
Exactly. The most successful engineers anchor their careers not to a specific tool or the framework of the month, but to a timeless mindset. It's about a pragmatic, laser-focused approach to problem solving. I love that quote attributed to Linus Torvalds. I am not a visionary. I'm an engineer.
Yeah.
I'm looking at the ground and I want to fix the pothole that's right in front of me before I fall in.
Love that. It prioritizes delivering real-world, tangible value over just chasing the latest shiny object.
Precisely.
And that philosophy seems built on an insatiable passion, a deep curiosity, and a genuine commitment to lifelong learning. It demands dedication to things like simplicity, clarity, and maintainability, always remembering that code is written primarily for other humans to read and understand.
And the humility to acknowledge what you don't know, coupled with the courage to actually tackle those hard, ambiguous problems that others might shy away from.
So the ascent to the top of software engineering, it really is a marathon, isn't it? A marathon of continuous improvement, strategic action, and a relentless focus on delivering meaningful value.
Well said.
Which brings us to our final thought for you today. Thinking about this apex engineer mindset, what pothole, big or small, in your current work environment could you start fixing today? How could you apply just one piece of this mindset right now? And how might that small, focused act begin to reshape not only your own trajectory, but maybe even the system around you?